Hi, this is Chuck Benedict, mentor for Team 997 Spartan Robotics in Corvallis, Oregon. I still on my testing kick and thought I would do a video, kind of a follow-up to the first video I did on automated testing for FRC robotics projects, um, because I'm working with a student right now who is kind of getting into automated testing and thought it would be useful to take the work that I started with him because we're just at the point where we have a test coded up and it builds, and now we're trying to run it to see if we can get the test to pass. And we run into a few difficulties trying to get the thing going, and I think those difficulties are likely to be stuff that everybody's going to encounter. And so I thought I would go through them just to help you out. Um, so again, funny story. He's busy working on our ball sorter subsystem, and he said, "Hey, I've got to put some timing logic in because I only want a certain thing to run every so often." And it's running in the context of the execute method, and so the roboRio runs it as fast as it runs it. And so he asked me what the best ways to go about, and I said, well, you might use futures. You might put some timing code in, but don't use thread sleep, because when you do that inside the execute method, it blocks the thread that other things are executing. So that's a no-no. But I said there's other techniques, so I showed him some stuff, and so he finally picked a technique, and that's all great. And he comes back to me and says, "All right, Chuck, I'm ready to test it. I want to run it." And I said, "Okay, you got a roboRio?" No, roboRio 1's on Robot 1, roboRio 2's on Robot 2, and I happen to have a roboRio at my lab, and it wasn't at the school, so we're back to the thing. Well, I don't have a roboRio, so I can't test it. And so I was like, no, wrong. You can test it. There are ways of testing it. Let's dive in and test it. And I told him, I said, by the way, I made a video for you that sort of described how to do testing. And of course, he didn't watch it. That's okay. Mentoring is a lot about repetition and gentle nudging and so forth. And as it turns out, I think he got a little excited about the fact that there's actually ways to run the code. So, mentors, if you're having trouble getting your students to test without the robot, just keep at it. You'll pique their interest. So what I thought I would do is first thing actually is that there's a poster on the thread that I put out there on Chief Delphi. No, you don't need a robot to test your code. He was having some trouble getting the test to actually run. He said they were skipped. I put a bunch of reasons out there, but it finally occurred to me that I think I know the reason. Gradle makes a determination as to whether or not your tests have succeeded running in the past and whether or not something has changed in your project to cause the need for them to run again. And it may well be that he has either run the test successfully in the past, and it indeed is determining that it doesn't need to run again, but he's wanting to for whatever reason, or maybe Gradle is incorrectly determining that the tests don't need to be run when they actually do. I don't know which is which. However, there is a way to kind of figure it out. I've run, so in when you run Gradle build will actually run your tests for you as part of the build process. And if your tests fail, it won't proceed with the build. You can also run .gradle w test, and that will just run the test suite. You can also run either of those things with ---- debug as a switch on the command line. And when you do that, you get this rather gnarly looking set of debug output. It's pretty nasty. There's a whole lot of stuff. And actually, a lot of the stuff is roboRio stuff, which you can thank the WPI-lib developers for doing all this junk for you, because it does a lot of stuff. In any case, the interesting stuff, so if you scroll down more toward the bottom, and if you see skipped down here, you know that Gradle tried to make a determination about whether you needed to do testing, and it, for whatever reason, decided you didn't. If you scroll up a little bit, and you have to watch carefully, but you will find the determination. So if you look right around here, you can see the Gradle task runner has this skip up-to-date task executor. So this is the, in the bowels of the Gradle code, this is where it's trying to determine whether or not your task should be run, your test task should be run. And it says task test is not up to date because task has failed previously. My guess is there's lots of other reasons that it'll give you as to why it did or did not run. So that could be helpful for you to try to figure out why your tests are not running, if indeed they're not, a way for you to kind of help yourself. So there you go. That might be useful. All right. Next thing I wanted to do is I wanted to, in real time, I've already sort of gone through this, but I've reverted my changes, and I want to go through these changes again in real time because I think I'll be able to explain things that are happening in a better way as you see them unfold than if I were to take cheat sheet notes and try to run through them. So we had gotten to the point where most of the stuff on my prior video on testing, I had already gone through with my student, and we had just gotten the project to build and to run the test, but we ran out of time, and we were getting an exception that wasn't related to his test, and so I'm going to take it from that point and go forward. So the first thing I'm going to do is this is in ball sorter testing. I'll put the link to the code on the project, and I'm going to make a branch here, and just to make sure I don't overwrite his stuff, I'll call it CCB feedback 2, or maybe how about timing test? That's probably better. All right. So let's simply run a test and see what happens. And, I'm not going to edit this. I probably should to make it a little easier for you to not have to sit and watch through all the stuff, but, bear with me. It just takes a little time here. Okay, first, failed. Why? Because edu WPI blah 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 base system not initialized exception at, and then this is actually the test right here. When we try to sort stuff is the name of the I think that's a command. Yeah, that's a command. So we try to instantiate the command, we get WPI complaining that the base system's not initialized. Yeah, I know that. We're not running on the roboRio. Thank you very much. Took me a while to figure out what the heck this is. On Chief Delphi, actually, I added to I have a thread called No, You Don't Need a Robot to Test Your Code. Down in that thread, I put a little code snippet here that fakes out WPI-lib to say, yeah, we know the roboRio is not running. Don't bother. Don't check. So this little bit of code here, you can just stick it. This is the test class, the unit test class that we have going here. You can stick this little static call here, and you'll need to also include or import the WPI library, WPI first dot, it's down here, WPI libj. Okay, that should make it happy. Okay, so now that's gone. So let's run this thing again now, and we should see that exception not happen because we've made WPI lib happy. Here we go. Okay, got past that error. Great, got another error. What the heck's going on here? So what the heck is up here? Okay, so now when you guys see stuff like this is actually the Java runtime environment actually barfing. And when you see stuff like this, it actually says where in it, the crash happened outside the Java virtual machine in native code. That usually signifies to you that it's not something you did. That usually signifies that that's something down in some JNI C code that normally WPI and others are taking care of for you. That's usually not something that you do. However, in this case, it's not true. And the unfortunate thing is, when people see this, they throw their hands up and go, this testing junk doesn't work. Never mind. Well, it's not true. And to even make matters worse, this exception right here is not particularly helpful. If you look through here, this has none of my code in it. So, you're like, well, couldn't write to some local port. I don't understand what's going on. Ignore this exception if this happens. What actually happens when a native crash like this occurs, the Java virtual machine writes a log file. You'll see over here, I've got this HS error PID, which is the program ID of a long number here, and a log file. Let's go have a look at this thing. Again, a lot of gobbledygook, a lot of registers, meaningless. Scroll down, but you do get a Java frame stack trace, which is hugely helpful. And here's all the JUnit stuff so that we know we're up this food chain a little bit. Our code has to be. Here we go. So FRC robot command sort stuff unit test. This is the first method that I see of my code that I know is on the stack. So we're in the middle of init. So as I keep going up the stack, I'm starting to see, looky here, FRC robot, and I'm doing some initting in my robot class. What does that tell me? It tells me that I have some sort of dependency in my sort stuff unit test. And yeah, of course, I'm calling sort stuff. That's what's under test. But sort stuff, what this must mean is sort stuff has got some dependency on my main robot class, and my main robot class looks like it's wired up to calling actual hardware, which of course I don't have actual hardware plugged in. And this is where we get into binding all of these things up together like in a ball of string where you can't pull them apart and test them separately. So that's really what we're going to kind of be up to here, is trying to uncouple and pull these things apart so that we can actually just test the thing that he's trying to test, which is his timing that he added into the command. So what do we have to do to figure that out? Let's go look at sort stuff unit test. And in particular, the line that it's barfing on is this one right here, right? So this is the class that's under test, right? So he's trying to test a method in this class. And up here, if we go into sort stuff, so let's go back up here into our subsystem. Sorry, that's our command, I guess. A pet peeve of mine, don't name things stuff. It drives me crazy. We're sorting balls, we're not sorting stuff. Anyway, okay, so back over here, he is calling, so he's calling the constructor, and it's barfing on the constructor. So let's go look at his constructor. Oh yeah, looky here, sort stuff requires robot.sorter. Guess what? Robot is the main robot program, and I am guessing there is some stuff in here that is calling directly out to hardware that doesn't exist. And yeah, I'm sure, and actually I think it's sorter. Let's go back to the crash. Sorry, I closed it. Let's go back to the crash. And yeah, inside sorter. So let's go back to robot again. Sorry if I'm jumping around. Right here, because we're calling the static robot class, Java is instantiating the static variables that are on the static robot class, and the very first thing is the sorter hardware, the sorter subsystem, which I'm sure if I go look in there, well, let's just go look in there. Oh yeah, looky here. he's instantiating the hardware by default inside the class. Actually, when the constructor gets called, then these things get instantiated. And of course, we're running this without roboRio, so we don't have this hardware. So therefore, the stuff that's in WPI go back to the crash dump. Yep, see, so all the stuff from WPI is trying to get instantiated, and eventually you go far enough up the food chain, and this actually makes sense inside the HAL. We get a native code crash because the HAL, it doesn't exist. Makes perfect sense. Okay, so what do you have to do to factor all this junk out so that we can not worry about it? So let's go look at in some more detail now at what he's trying to do. Again, he is trying to instantiate sort stuff. Sort stuff has a dependency on the sorter, which is fine, that makes sense, but we don't want to be relying on a static sorter sitting on the robot class. We just want to be passed in a sorter subsystem into our command so that we can just interact with it. And in fact, you can see that he already started to do that because I was helping him and basically saying you don't want to tightly couple these things together. You want to inject dependencies into your classes so that you can decouple them at test time. But he failed to take this dependency out. So let's just simply do that. Now the sorter that we're requiring is not the static sorter that's sitting over here. And again, this is a problem, but we'll get back to that. The sorter that we are going to be requiring is actually the sorter that's coming into the constructor. Now let's run the test again and let's see what happens. Some of you guys may find debugging and diagnosing things tedious. Actually, that's the stuff that I love. I love diagnostics almost more than coding. So what happened again? We got another exception. Oh no, what is it? Same kind of junk, WPI, HAL, DLL, so we know we've got some of the dependencies we need to unwind. Okay. Kind of looks like the same thing, huh? Let me see here. This is in, oh no, not the same thing. This is actually now in the initialize method of sort stuff. Right. Exactly. So we were in the constructor. So we made it past the constructor, but now we're calling initialize, which makes sense because these. So we're trying to test a command, and again, we want to try to simulate what the roboRio is going to do with our command when it starts up our command. And the first thing that it does is it calls initialize. So we need to simulate calling initialize, and you'll actually see in his test, he does that exact thing right there. That's what you should do. That's good stuff. So back over to sort stuff. Now what's the problem? Well, again, we're making a reference to the static robot class, and we're calling sorter yet again. And so that's, this sorter is referencing actual hardware and it doesn't exist. So this reset scene values sitting on the sorter class shouldn't be calling on the robot static. It should actually be calling on the sorter that we passed in as an instance variable, this sorter, to our sort stuff command. Here we go. Run the test again. Alrighty, another gnarly exception. What does this one say? All right, so after I fixed this code right here to not reference my static robot class, it's got another exception, and it's different, which means I'm making progress. That's good. we can see now that we are in our test. Good stuff. We're calling the execute method. Good stuff on sort stuff, which is, again, we're simulating what the roboRio is going to do with our command. So let's go look at sort stuff execute and see what the heck's going on in here. I can tell right away. Look at this. We are calling again the robot static class inside our command here. No, 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 don't do that. So thing is, though, this sorting balls, this is a flag, I believe, that he set to actually be able to enable or disable globally the sorter mechanism, which is fine, makes perfect sense. However, let's not set this thing statically and again bind up our classes together. Let's decouple this stuff. So let's just simply add on the constructor an enabled, I can spell it right, an enabled flag, and then let's just set up Boolean enabled here. Let's set our member variable like so. And then down here, instead of doing this junk, let's just say enabled. Okay, takes that dependency out. And let me go back over to robot and take this out so that people don't get confused. Alrighty. And I'm probably going to have to fix where I'm calling some constructors. Yep, indeed I am. So let's just pass true here. And hopefully that makes everything happy. Oh yeah, probably this one's going to have to get fixed as well. That's fine. Everything turns green. That's lovely. So now let's run the build one more time. Actually, I didn't want to run the build. I wanted to run the test. I think it's going to run the test as well. Oh, looky. I recognize this code. He put some print lines in here to kind of help him see what's going on. Yeah, I don't know whether that's good or not. That's his business to deal with. And oh, looky here, the test failed. The test itself failed. It didn't fail because of other problems. And actually, this is the verification on his test. This is down here on this verify. We're trying to determine whether manage queue on the sorter mock subsystem got called 10 times. Well, obviously it didn't get called 10 times, it got called more. So, hey, this is a bug in his code. That's fine. That's the point of what this is trying to do. However, we now actually have his command actually under test and our test running after decoupling and pulling apart our command and our subsystems so that they're not bound to the robot static class. So hopefully you found this helpful, and sorry you had to wait and kind of watch me go through this, but maybe you'll find that interesting enough to where when you see these errors, you don't just sort of throw your hands up and go, it's not working. This testing stuff is junk. Anyway, thank you for watching.